Okay, let's go. I'm recording. We are going to start today on pH of weak acids and bases. So let's just jump in here. Calculate the magnitude of the equilibrium. So when we think equilibrium constant, we think of K, big K. But now we're talking about acids and bases. So this is going to be Ka and Kb. A for acid, B for base. For benzoic acid, which is HC7H5O2, if 0.1 molar solution has a pH of 2.59, I'm going to add another digit in there, 0. Okay, so we cannot do straight away and take the pH and do a get the H plus because this is a weak acid. So the first thing what we want to do is anytime you have a weak acid, you need to add the weak acid or your weak base to water. And we're going to do a rice table. So RICE. So our weak acid is HC7H5O2. We're going to add it to water. And when we add it to water, we end up getting C7H5O2 negative plus H3O positive. We know it's an acid, it starts with an H. Therefore, when we add it to water, we better get the hydronium ion. Okay, the H3O plus. So we are going to do our initial concentration is 0.100 molar of our weak acid. Water goes away, it's not in our equation. And we have nothing of our conjugate base and our H3O plus. It's aqueous, that's all. And then we have our change is going to be our coefficient, so minus x plus x plus x. And our equilibrium is going to be 0.100 molar minus x. And we have x and x. So next, write your equilibrium expression. So this is a acid. So Ka is going to be C7H5O2 minus times the concentration of H3O plus over HC7H5O2. So how are we going to solve for Ka? How do we solve for x? So we have the pH is 2.590. So I can take the 10 to the power of that. 10 to the negative 2.590, and that's going to give me my H plus concentration. So get that for me.
0.00257.
So H plus concentration is 0.00257. And that equals my X. So now we can plug our X in. So 0.00257 squared over 0.0974. So what do y'all get for Ka? 6.78 times 10 to the negative fifth. Questions?
So is the KB the same thing except for x we put 10 to the negative 1.7 for the x?
No, Kb would be if we were talking about bases, but this is an acid. Let's do another one. Calculate the magnitude of the equilibrium constant for an aqueous solution of ammonia. If 0.1 molar solution has a pH of 11.13. So this is a base. So take your ammonia, NH3, add it to water. We know one of our things we better get is OH minus, and therefore we should get NH4 plus. So our initial concentration is 0.1 molar. Water goes away. 0 for hydroxide, 0 for NH4 plus. Our change is minus X, plus X, plus X. And our equation is going to be 0.1 minus X, X, and X at equilibrium. So Kb, they gave us Kb? No, we're calculating Kb. So Kb is going to be equal to NH4 plus times OH minus over NH3. Now pH is 11. Oh, I want to add another 0 there because of the. So it's 11.130. So we're going to take pH and that is so pH is going to be equal to 14. Oh no. We're dealing with OH, right? So we need to have POH. So POH is going to be 14 minus 11.130, which is 2.870. And now we can find our OH concentration. So what is our OH concentration? 0.00135 big M. And that is our X. So we can plug that in. So 0.00135 squared over 0.0987.
Yeah.
And what does Kb equal? 1.85 times 10 to the negative fifth. You would, Ka, well, we know what Kw is, right? So Kw is Ka times Kb.
Wouldn't it be 845?
8, 4, 5.
And because of the sig figs is a...
Oh, yeah. Wait, we have 3, no,
No?
because it's 3 decimal places. The pH is 3 decimal places, so our answer has to be 3 sig figs.
What if it was just 2?
Huh? I added that 0 in there. All right. Last one.
Wait, what did you get for that?
1.85 times 10 to the minus 5. All right, last one. This one, you have homework. Your homework is based on this too. Calculate the pH of a solution, which is 0.715 molar CH3NH2, methylamine. Kb equals 4.14 times 10 to the minus 4. So first thing, is this an acid or a weak acid or weak base? Weak base. So how do we know? Because it's Kb. Yes, and also amines are bases, are basic. So 2 key things there for you. Yes.
What about amino acids? Because that's an amino acid. Does that apply for all amino acids?
But aren't the... I'll have to look up that answer. Because they all have the amine group on them. Aren't they bases?
Yeah, I thought some of them were acids. Were actually acids also, because they have 3 hydrogen.
I think it probably depends on the name, too. All right. So first of all, what do we need to do? Rice table. So we need to, what needs to go in our rice table? Plus H2O. Add it to water. Water goes away. We know this is going to be a base. So CH3NH, it accepts. So NH3 plus an OH minus. Initially, we have 0.712 molar of our methylamine and nothing of the other part. Our change is minus X, plus X, plus X. And at equilibrium, we have 0.712 minus X, plus X, and plus X. So there's one part of our setup. The next thing is we're given Kb. So let's write our Kb expression. Kb is equal to CH3NH3 plus times the concentration of OH minus over CH3NH2 Kb. We have a value for Kb, and Kb is 4.4 times 10 to the minus 4. We can substitute everything we know so far. X squared over 0.712 minus X. Here what we're going to do is we're going to say that X is negligible. I want to give you guys a rule here in a minute to figure out if you can actually say that it is negligible or not. But right now we're going to assume it's negligible. So solve for X.
Point
0.0177, and that is molarity. And X, I always go back to my rice table and see what is X. Was X OH or H plus? And here it was OH minus. So now I can take the negative log of that, and it will get me my POH. Which is 1.75. 3 sig figs, we go 3 decimal places. 1.7, what? 52. Therefore, my pH is going to be 12.2 what? 248. So did we solve the problem? Calculate pH, yes. All right, so I'm going to tell you right here, 5% rural dissociation, or 5% dissociation rule. You can negate or say that X is negligible if you fall under the 5% dissociation rule. So how do we figure that out? What you need to do is you need to take your X. So what you find for X to be, and you're going to put it over your original concentration times 100. So here our X was 0.0177. Our original concentration was 0.712. Times it by 100 and tell me what's our percent. 2.5%. So it is less than 5%. So we can we can say it's negligible. So it has to be less than 5% to be negligible. Yes.
If we wanted to just do extra safe.
If you wanted to solve for it, use it, you can.
I just use the regular quadratic formula, and my X was only 0.0005. So I got 0.01748.
Yeah.
Is it still 80?
It's okay. I'll tell you, in the multiple choice questions, they won't give you quadratic. And they're really not going to give you much of a quadratic anyways because people don't have quad form or any of that stuff. So or they do give you a quadratic, it's going to be something that's simple. Okay. So any questions over pH for weak acid versus weak base? They're pretty simple, just using the rice tables. Okay, your homework is that first page.